view at my YouTube channel. I'm going to be getting some other stuff up there later today. Okay, so we've introduced yesterday some basic mechanisms of creating populations of pre-specified size, and also we saw how we could create a network of individuals from a one network category. We looked at distance-based networks. We're going to be expanding that today to see additional types of networks. However, it's quite typical for many domains to be concerned with open populations. The use of open population, or the desire to characterize open populations of immigration, death, and birth, is one of the motivations for engaging in dynamic modeling as opposed to sort of simply following cohorts over time. And moreover, research suggests that for many sorts of situations in network dynamics, the change of networks over time has a disproportionate impact on dynamics of the overall system over time when compared with static networks. So for those who follow the SDI literature, issues of concurrency, for example, are of great interest. Concurrent connections, because they provide those thoroughfares for infection to spread, not just in dyads from one person to another, but from a third party through to another party who may not be in direct contact with them. Similarly, network dynamics are things that we found very important with some of our work with infectious disease spread. Fortunately, AnyLogic provides strong support for adding and removing population members and adding and removing connections. Excuse me, I will modify this. It provides support for adding and removing population members and strong support for adding and removing connections. There's an ugliness with the first one that we'll see at some point, probably. It ain't totally pretty, but AnyLogic 7 is cleaning it up. However, the support here does not get a direct graphical user interface support, and you're going to end up having to write a little bit of Java code of this sort. So, for example, if we have a population, maybe it's called a pop. To add a person to that population, we would say add underbar pop in the parameters associated with that person. We saw parameters yesterday. The idea that we could have income and sex, for example, specified for a person as parameters, or maybe it's their initial age. So we can do add underbar pop and specify their income and specify a person's sex for the person we want to add. And we can also delete from a population with, say, remove underbar pop. These are so-called methods associated with the object that contains that population, so with main, for example. Similarly, we're going to be able to connect two agents together with agent1.connect to agent2, or agent A.disconnect from agent B. So I'd like to load in a model where we see this. I would suggest that you load in a model from the O drive called Minimalist Network ABM model. Okay, so I'm going to go do this as we did yesterday myself, and we'll go through this steps together to add in a dynamic population and add in some network dynamics. Okay, this is actually a model that we essentially reproduced yesterday, Minimalist Network ABM model. So if you have that model still open, you're welcome to use it as well. It's the model we created in the afternoon. Okay. Okay, so TA should be poised here, should be ready to deploy. Once you've got that loaded, I'd like to add immigration in. And we're going to do this using what we call an event. Okay. We're going to introduce an event that periodically adds a person to the population. Okay? We're going to go back and reflect on how events can be used more generally in a little bit, but if we wanted to add people into our population over time, does anyone want to sort of hazard a guess as to where we would go to add them? What class would be responsible for adding people into the population over time? So if you want to load it from the O drive, you can, if those of you who are seeking to load it from the O drive, you can go to the O drive, so file, open, select the O drive, and select minimalist network ADN model. Okay, so what class would be associated with adding people to a population, do you think? What class is responsible for maintaining the population in AnyLogic? The main class, yeah. The main class, and they're associated with an environment there. So what we're going to do, ladies and gentlemen, is to add an event to the main class. So if you double click on main here, so who needs TA help here? Who needs TA help? Okay. So what we're going to do here is to add an event to this environment. So, or excuse me, to the main class. So over here in the palette, you can drag an event in that's an immigration event. Okay. Now this event conceptually is going to represent some incident that occurs with a certain set of rules associated with it. It may be a certain frequency, a chance per unit time of occurring, a rate, as we used the notion yesterday, or it may be a one-time thing with a timeout that occurs only once, or it may be based on a condition. In this case, we'll make it a rate, and we'll make the rate, say, 100 people per year. Excuse me, that's per day is the time units here. So make it one person per day. Sure. Such as, could you give an example? Okay. Sure. Okay, so if we had the immigration process is going through different stages, my temptation would be to have an event that starts it off, and then if those stages are, for example, reflective of that you have an individual needs to apply, and then they need to be, examined, and they have to be approved, and then maybe they have to, get their affairs in order and then relocate or something like that. One thing you could do is create actually agents that are in those, starting at the very first stage when they apply. They're in a separate population of people who are sort of in the queue, and then they progress through a set of stages and then come out at the, when they finally get approval, they could then be added to the main population. But another possibility is you could have a representation using a discrete event model, and Scott and I will be showing some examples of this, of hybrid models, where that process is captured and the queues associated with that process are captured in such a way that that you have them progressing through those stages in a discrete event model, and would then, when they emerge, they would be added to the main population. Why would you do that? Well, when you're choosing between these sorts of modeling, one versus another, for example, a key question will be, to what degree the scope of the model really includes factors which change that process? In other words, are you going to be examining things which would, devotion of resources which might speed up immigration as part of your model? If that's part of the goal of your model, that the details of that process, then representing it in a more fulsome way, in a way that's richer, might be worthwhile. For example, doing it in a discrete event model would allow you to say, well, suppose we had more reviewers here in Saskatchewan for reviewing the professional qualifications of people so that we could shorten the time to review a given application and therefore allow people to come more quickly. If that's part of the scope of your model, then representing it in greater detail is advised. If not, you might represent it with a state chart with an agent, or even just only model the final stage of it.
Sorry, I was like trying to see it
Yeah.
in an outbreak.
Okay. Okay.
We have, if you want to take into consideration, let's say, like both different population.
Okay.
You say events like immigration and
Yeah.
say,
Sure.
whether events.
Okay.
So like complex
Yeah.
scenarios, you make it
Yeah, so you'd have different events for different types of things. So you'd have a.
If the event has different rates, say different seasons.
Yes,
Or
yes.
maybe the hurricane or
Yes.
whatever.
Sure. You could have, generally speaking, you'd have different events for different sorts of events. But if you're saying within a given event category, you'd have sort of different schedules associated with them. Some being more seasonal, some being more sort of stochastic at any time of the year. You could have two different classes, two different events representing those different sort of types of occurrences of that, sort of the different drivers or stochastics associated with different subclasses of those types of things. So you might have some weather events that are pretty much independent of certain types of seasonality and certain that are highly seasonal, and so you might have those as different events. But we're talking in abstractions here, so I like to do with concrete cases, and I'd be glad to talk with you one-on-one further about this, but I do want to illustrate this, so we could talk about it separately. So, okay, folks, so we have an immigration event that we dragged in here, and we're going to need to, when an immigration event occurs, we're going to need to add this person to the population. Yes?
Some of the people that are opening the one that you indicated,
Yes.
what's different than the one you have?
Okay, that's fine. I'll go open it then, and then we'll, because I was operating off the one that we built yesterday. So here I'll load it in then. Okay. So minimalist network ABM model, okay, fine. Okay, so let me close these up so that we don't get confused about what's in which model. Okay, there we go. Okay, so the minimalist network ABM model that they should be seeing is, I think, this one here, something like that. Yeah. Okay. So what we're going to do is we're going to add an event in for representing immigration, something like that. So try that again, immigration. And this could be done at a rate of, say, one person per day on average. What does that mean? It means the inter-arrival time is exponentially distributed for what we talked about here yesterday. So there's a certain chance per unit time a person will come in. It's a Poisson arrival. And in order to add a person to the population, we would ask ourselves as main to do, okay, add underbar population. So add a person to the population. That's what accomplishes that task. In this case, a person has no parameters, so there's no parameters we need to specify at the current time. So we could just do add underbar population. Okay. We should probably save this model to avoid overwriting. Well, you folks can't override it, but I'll save it to minimalist network ABM model with open population. So, minimalist network ABM model with open population ABMB 2013. Okay? Okay. So we're going to run the basic simulation here. And what we're going to see is there's actually some mortality occurring here, but we have some people appearing as well. You'll notice that they're appearing here within the space. There's some mortality occurring as well due to aspects of this model. So we have, for example, here, and this was, I should have cut this out of the model. If we go into person, you'll notice that there's sort of a particularly simplistic state chart right now, and we have this transition here being associated with a death event, which removes the population, removes the person from the population. Okay, so we have people coming in, being added to the population by the event, and then we have people leaving the population by virtue of mortality, dying after with some mortality rate. I'd like people to, based on the discussion yesterday, I'd like people to explain what the meaning of this is. So we saw yesterday the basics of this, and I'd like you to understand, piece for me through what the meaning of this, what job does this accomplish? So we have an individual in a living state, there's a transition out, which is a rate transition. So could someone here who's feeling adventurous explain to me what's going on here? So are these people dying at a fixed age? How are they dying? According to what sort of logic? There's a mortality rate. I'm sorry? Yep, so there's a mortality rate, which is a parameter living in Maine. And what is this called to this dot get Maine doing? Can anyone tell me? Sorry? Yeah, so it's getting the main reference to the main class, and it's asking the main class, okay, give me your mortality rate. What is this action doing, based on what I've told you thus far? This dot get main dot remove population. I'm sorry? Okay, so what is it doing? It's removing them from the population. Why do I pass it this? So when I call, first of all, whose remove population am I calling? It's important to learn to read these things. So this is being called on main. So I am saying, hey, I'm an agent. I'm some agent here, the agent that's dying. Let me ask for my associated main, the main that's sort of in which I'm located, that's maintaining the whole model, this edifice of the model. So I say, okay, get a reference to main. And then I'm asking main, okay, remove, what is this representing? Remove me. That's me. That's saying, because otherwise it doesn't know who to remove, right? You say remove. Oh, who?
What else could you put in there?
You can put another agent.
Like randomly.
Yeah, you could put in, if your model incorporated homicide, you could put, some other individual in there. Or if two companies merge, you could eliminate, if Google bought AnyLogic, it could say remove AnyLogic. And,
You didn't catch it.
yeah,
You can tell the joke in text.
don't worry, I don't have any insider knowledge. So remove population, this is saying remove me. So here we have an open population captured death as well. So removing myself. And this is occurring for a given person, there's just some mortality rate applying. We could have this mortality rate vary on a per person basis. In fact, it can vary over time as our age progresses, as our comorbidities progress, various risk factors, etc. So ladies and gentlemen, what we're seeing here is sort of two components of this. One is we have an immigration event where people are being
added to the population with this certain chance per unit time. And now we have an event associated with death occurring as well, with removing from the population. But does anyone see something kind of awry with this model? Let's run this and take a look at what's going on. You can see death occurring, but what's going on that doesn't seem quite right? Sorry? Okay, there's no connections being added. So let's go add in connections, a representation of those connections between people. For reasons of computational efficiency, AnyLogic, when you add a person, doesn't automatically consider that the connections that need to be added and take care of all that. But it's very easy to do. So let's go to the main class. We've got an immigration. Now, as a software engineer, what I would urge you to do here is to actually call a function that represents adding a person to the population and wiring their network in. And it would be called, create new person, and it would take care of all the work that's needed. But for simplicity right now, visually, I'm just going to add in the component here. What we need to do is we need to basically ask it to reform the network. So of all the things we see on the screen, who's responsible here for maintaining the network? Do you remember that? We saw a glimpse of that yesterday. Where did we go to specify, for example, it's a distance-based network? It was in the environment. Actually. And we'll see more of this today. So we need to actually ask the environment to apply the network, okay? We have to say, hey, environment, refresh the network. So actually, what you have to say is, okay, this dot environment, so in other words, my environment, apply the network, okay? Who needs help here? Who needs TA help? Okay, a layout is going to basically allow you to, when a new person comes in, put them in, for example, a ring shape. It basically has to do with where they're located, okay? Whereas apply network basically has to do with connecting them up to the topology, who's connected with who. So whereas layout has to do with their spatial location. So, so here we have apply network. So once we've done that, so this dot environment dot apply network. So what are we doing here? We're asking, okay, get my environment first, and we're asking the environment, okay, go apply your network. Sort of recompute, go recalculate your network. You'll notice this has to be with a capital N. By convention, Java method names, in other words, when you ask a Java object to do something, it has a lower first case letter, but subsequent words are capitalized, the first letter, in a convention known as camel case, and that allows you visually to sort of recognize the words there. So let's run the model now. And now let's speed it up. And now we see a network where the people coming in are wired into the network automatically. The network knits together these new people coming in a fashion that reforms the network. Now, ladies and gentlemen, notice that the model completed at time 100 here. Where would I go within AnyLogic? Where would I go to allow for a scenario to run for a longer period of time? What dictates a scenario and what's assumed in the scenario, including how long it should run? Where would I go in my model hierarchy? Over here. Sorry?
go to specify the characteristics of the scenario, like the assumptions of that scenario. Simulation, yeah, that's where scenario information lives. In other words, the experiments, the things marked as X's. So if we go there, ladies and gentlemen, you go to model time, you could see you can either specify, stop it at a specified time, or you can say never. Let's say never. And now we'll see an open population in all its glory. So now we have a population that's evolving in an open way. Empires rise and fall, and networks are formed and broken as people immigrate and as people die. How many people would like to see a baby born in this model? Okay. Let's introduce a representation of birth. Okay. So what I'd like to go to person, and we're going to now have a representation of persons where a person can become pregnant, and after 9 months of pregnancy, a baby will be born to the population. So, ladies and gentlemen, help me do this. Tell me what to do. So, suppose we wanted to allow, for the moment, suppose we engage in a stylized model, and we want all people to be able to become pregnant and give birth. How might I represent the fact that someone's either pregnant or not pregnant, and the transitions between them? I might use a what? A state chart. Good. So let's create a state chart here, ladies and gentlemen. So double click on person so that that's open, and let's go add a state. So, well, you tell me, how do I add a state chart? Tell me what to do. How do I create a state chart? Someone a non-TA want to lead? So how do I go state chart and okay, good, excellent. And let's call it pregnancy state chart. Something like that, okay. One point of note, names matter. Names matter, okay? Names are often one of the key sort of hints you can give people as to what's going on in the model. And if you use names consistently, you can save yourself a lot of time and a lot of grief, okay? Okay. So this is a good question. While they're living, okay, so maybe I should have posed that to the group. How would we said we could represent pregnancy as a state chart. What might the states in that state chart be? I'll try to address your question. What might the states be?
Entry, maybe like more population.
Well, this is at an individual level, so we're dealing with a particular person. Right? And what might the states relevant to pregnancy be that we'll want to represent?
First trimester, second trimester.
We could do that. That may be an adequate.
You may say that because I didn't really think about it again. What do we want to represent?
Yeah.
So is it birth transitions to they all born and then they influence
Right.
transition to a child to a young adult.
Right. Okay, that's a good question. So what level of abstraction? My focus here was purely to illustrate how as a demographic process birth could be added in a simple fashion. So we could break it out into multiple trimesters and multiple stages of the life course. So you can have children who are not of reproductive age and reproductive age.
But what's the research?
Well, here I'm not conducting a research question. I'm trying to illustrate how we can do something in AnyLogic. So maybe that, but you're absolutely right, with a real model that you're building up, you would have to ask, what's the scope here? I mean, what am I trying to look at prenatal factors and the ways they affect, fetal development in a way that might affect the life course? If so, capturing the sort of detailed timing associated with pregnancy would be worthwhile. On the other hand, if my goal was to look at capturing delays associated with the impact of some intervention, when we might see positive birth outcomes reflective of that, I might deal with a more sort of aggregate model. Here, what I'd like to suggest is, to cut this short, I'd like to suggest that we have a non-pregnant state and a pregnant state, and I'd like to have a transition out of the pregnant state that will be associated with return from the mother to the non-pregnant state, but a baby being produced.
So how would I do that mechanically here? Good. Question?
Not really a question, but I was thinking that the transition would then be like if a mother is pregnant, then after the 9 months, then they are two.
Okay. Okay, good. So,
That's into an addition of one, right?
yeah,
It's not-
good.
The movement is not from one state to another, but from being one agent, for example, to being two agents.
Okay, but there is, I would argue the mother still exists, and the mother could be represented in this way very conveniently using states. Okay? So how would I add a non-pregnant state to this model? Sorry? Pregnant or non-pregnant? I could. And that would capture information, but in terms of triggering the birth at a specific time, it turns out it's easier to do within a state chart type of situation. You could have a pregnant variable, is pregnant variable, but then the question is, how would you trigger it to change, back to non-pregnant after 9 months? And you could do that with an event, it turns out, or actually what you do is what's called a dynamic event, but it's going to be more involved than doing it the way I'm just going to show. Okay, so we could have a sort of state that's non-pregnant, and then we could have a state that's pregnant. Okay, and we could have a transition between them that represents conception, right? This transition represents the conception event. Now, one of the things from a didactic perspective that I wanted to bring out here, well, two of the things would be associated with the next transition. So, okay, first of all, where would the transition go for the pregnancy coming to term? What would happen for the mom at the time the pregnancy comes to term, at the time the pregnancy is completed? Where would the transition go from where to where? Pregnant to non-pregnant, and so that's one thing. What sort of transition would be associated with? So this would be, transition might be delivery, something like that. What sort of transition would it be? What sort of, okay, sorry? Yeah, that's right, some elapsed time, which is best approximated out of all these things by a timeout. Now, you could argue that, we should really have a parameter drawn from a distribution for delivery times. Then we'd have some variation. But for now, what I'm going to say is 9 months times, times 30 days each. What does anyone happen to know off the top of the head the sort of average time for delivery? Is it anyone know? Is it 270 days or 275 or? Sorry? Okay, I'll do 9 times 30 as 266? Yeah. Sure, sure, yep, we could draw it, that's great. Sure, that's actually very nice. So maybe we want to draw this from I don't know what sort of distribution, it might be normally distributed, but I don't. Sure, okay, so a log normal distribution, now, for this to be a log normal distribution whose mean is given by 266, could take the log of that, and that would be 5.5834, and then I don't know what the log standard deviation is for this. Remember here, if we go here, we could see it's looking for mu and then sigma here, and so sigma, I'm not sure what sigma is associated with it, but maybe I'll say a sigma of 1, and then a minimum value is not something, the minimum would be 0. So this would be, okay, yeah, 5.58. Where did I come up with that? All I did is I took the natural log of 266, which was given as the mean. Yes? Mm. No, it just means that, so this is, you have the option here, so the log normal distribution in AnyLogic, this is going to represent a sort of right, a distribution with a fairly heavy tail to the right. And all it's saying is, what's the minimum value that you can get here out of a distribution like this? And sometimes you want to truncate it, like to be the minimum value to be 250 days or something like that. And all I'm saying is essentially the minimum 0, which you're never going to get anyway. So essentially it's a non-binding limit. But you can impose minima here where it's going to draw from the distribution to the right of that. That's what that minimum represents.
I think that minimum should be the minimum age of viability.
No.
Okay.
No, because then what you need to do is you need to shift the entire curve to the right.
Okay. I have a solution. What if we say percentage of the gender population?
Yeah.
Like,
Yeah.
like the best and every 9 months.
Well, okay. So if you really wanted to do this, in a fully grounded way, you would have a empirical distribution given by data on birth timings in a representative sort of setting for your model, and you could draw from that custom distribution. And AnyLogic does support that. So I don't know that it's a shift though. It doesn't. It's not.
No.
Yeah.
I'm not saying use minimum. I'm saying instead of
Yeah.
saying log normal,
Yeah.
what was it?
5.58.
5.5610. What you want to do is write, say, 5 weeks is 35 days, so like 231 plus log normal of whatever the square root of 35 days, or the logarithm of 35 days is, to get this mean. So at that point, you're not going to have any births before viability, which is before this point, but I just use this because when my son was born. But my point is, if you do a minimum, you're actually changing the shape of your distribution, most likely. And so that's
Okay.
why I'm saying you just use this different expression to get a much better actual marking out.
Yeah.
So.
Yeah. I mean, as I mentioned, log normal is kind of speculative here. It's
Sure.
wholly speculative here as to whether it's log normal. I suspect it's not log normal. And really, what we could do if we really wanted to try to deal with the more detailed information on this, we could make use of what's called a table function and then use a empirical distribution based on that table function. Essentially impose a histogram and have a cumulative and have a custom distribution based on the histogram that draws values from that histogram, and it probably would not be exactly parametrically captured. But let's I don't want to go into this too much right now because it's really diminishing returns, and we're speculating about an area where we'd really want more information about what's going on. So I will impose. I do like the suggestion, though, of drawing a value from a distribution just to show in principle how this is done. So the point here is we have a timeout. When a given woman comes into the pregnancy, she will deliver some fixed amount of time later. But for a particular pregnancy, that the amount of time that she'll spend in that pregnancy will be drawn from this distribution. So different pregnancies will have different lengths associated with them. This provides a way of imposing a distribution on how long you spend in a state. Okay. So that was point one I wanted to get across with this, that we have a timeout, and I really like the idea of drawing it from a distribution, even though this distribution is probably not empirically grounded. It's probably not going to be exactly log normal, and we don't know what this the log standard deviation is anyway, the sigma. So, okay, the second thing is what else has to happen at the time of delivery? The mom goes back to the normal pregnant state, but what else happens? Okay, so someone needs to be added to the population. So tell me how to do that based on what we've seen. First of all, where does the population live in the model? It's in Maine. So how do we tell Maine to add a baby to the population? How do we get a reference to Maine so we can talk with Maine? This dot get under bar Maine, and then TAs circulate, add population. Okay. Yeah, this gets a reference to Maine so that I can talk with Maine. I know how to address it. I have to tell Maine, hey, go add a population. This just gets the Maine associated with Maine. It gets sort of line associated Maine. This is going to be a lot easier in AnyLogic 7. You'll just have Maine dot this, but or this dot Maine dot that. Yes. Okay, so we're going to do that in just a minute. Yeah, so good question. That's part of this exercise. Okay, so here we have delivery going on, and ladies and gentlemen, let's go back to Maine. So first of all, people need TA help. TA. Others? TA help over there. Oh yes. So, okay, so this transition here, that's a good question, we need to impose something. So there should be some fertility rate, or, if we add no distinction by sex, it would be a birth rate. Let's go add a fertility rate to the model. Let's suppose we wanted to have we could have time varying fertility based on age, but let's simplify it. And suppose that we wanted in a scenario to be able to specify the fertility rate, okay, for the model to assume. So suppose we want in an experiment to be able to say what the fertility rate is for this model. How do we do that? So we want the experiment to be able to state the fertility rate for the entire model. What does that fertility rate need to be then? It needs to be a what?
needs parameter of what? For the experiment to be specifying the assumption, that needs to be a parameter of what? Of main. Of main. Yeah.
We have a parameter already.
Okay, for main. We have mortality rate, so we'll have a fertility rate then, okay? So let's go up to main, double click on main, and add fertility rate. That needs to be at main for it to be specified by the experiment, okay? So a fertility rate here needs to be specified. Okay, so now we have a fertility rate there, and we'll give it a default value of, say, again, I mean, we're abstracting over a lot of things here, including reproductive years, but we'll make it a fertility rate of, say, 0.1. So excuse me, this is on a per day basis, so you have to be careful with that. 0.1 divided by 365. So on a per year basis, it's 0.1. Because it's 0.1 divided by 365, this will not be simply an integer computation, but you may want to make it clear that in general you want to be cautious about that. So we have a fertility rate whose default value is given by this in main. Yes. Yes. Yes, you can. Yes. It unfortunately, this is a feature of C-based languages that are a certain family of languages. You know, they have integer division, integer multiplication was very important when they were first conceived in the 1970s, and there's a logic to it, but it has led many people to run afoul of it. And the easiest thing to do is to put a dot zero, and it will then be a floating point quantity, okay, a double precision. Yeah. Yeah. Yeah, it's a great. Let's do that. I love that idea. Okay. Okay. Yes, we could. So we should be able to do fertility rate equals mortality rate here. Now, the reason I was vacillating there is because fertility rate here had to be added after mortality rate. Otherwise, there needs to be sort of clear which one is set first. You couldn't have them both set on each other, right? And in this case, since mortality rate is the first parameter, we could have fertility rate be dependent on that. I think that should work just fine within AnyLogic based on something I've seen. So we could have fertility rate be the same as mortality rate. Technically, we'd be dealing with the birth rate, because then we're dealing with the rate for all people in the population, not just for women. And when we confine fertility to only occur for women, we'll have to make it presumably twice the mortality if only half the population is women for it to be imbalanced. But okay, so let's go down to person again. So if we have that fertility rate that lives in Maine, how would I use that here then in this state chart? Tell me what to do, folks. Like a mother variable? We could have a mother variable, but we don't right now, like who my mother is. That would be straightforward to add. And in fact, we'll do that in a minute, just because you asked. But for this occurrence of pregnancy, how would I make it depend on the fertility rate? Oh, okay, I'm in person. Yep. For the transition, yeah. It's a rate transition. Excellent. Yep. this dot get main, begin paren, end paren, dot fertility rate in Maine. I need to ask Maine, I need to get my reference to Maine and say, hey, what's your fertility rate? Beautiful. Okay. So there's a rate going here, getting the fertility rate there. Okay. Okay. So we're going to have fertility rate occurring. It's just a chance per unit time of becoming pregnant according to fertility rate, and then delivery is going to occur. Now, actually, this is going to throw off slightly the balance of the population because women are going to be pregnant for 9 months' time, and during that time, they're not going to be able to become pregnant again, which might limit the balance achieved with mortality, but I'd have to think about that. Okay, so here we have delivery and we have conception. You'll notice that conception, the name is not shown for the transition. For whatever reason out here, if you click on this box, show name, then it will show. So you can actually turn on and off the names used to sort of associated with these transitions, okay? So here we have conception occurring in delivery. So shall we run this model? Okay. So right now we have people being added in. Let's go look at particular individuals. So here's different individuals. Here's one that's pregnant, for example, and this is the time until the delivery is counting down. You'll notice that the delivery time is okay. Now the model. Oops, I just yeah. Okay, there we go. So we have these individuals in the population, and okay, oh that's okay. Well, that's most interesting. Scott, you okay. Well, that's quite interesting that that's occurring. But, I haven't seen that before. But fundamentally, we have the ability to sort of watch the members of this population, and some of them will be pregnant and some not. And the time until they leave this state is shown here in blue. Similarly, the time until they will become pregnant is shown here in blue as well, okay? Associated with each of those transitions. So who needs TA help here? Okay, so what I'd like to suggest then is now we go and put in 2 of the elaborations requested by people. So how would if I wanted to limit fertility to women, how would I distinguish women? What's one way I can distinguish women and men based on what we did yesterday? Sorry? Okay, a variable, or more specifically a parameter that's specified when they're first created, whether it's male or female. So where does that parameter go? Does it go in main? Goes in person. So double click on person, drag a parameter into person, and we'll call it sex. Now, we can make this an integer, for example. We could actually denote it as a Boolean, is male or is female. For now, we'll make it an integer to spare certain types of difficulties. There's also a very nice way you could make it what's called an enum, which would basically say, allow you to spell out this is a male, this is a female, and be very explicit about that. But for now, we'll just make it an int, okay? And that's good. We know how to specify that. How would I make it so that only women can become pregnant? Well, it turns out that there's this quantity called guard here, okay? And a guard will basically be used to check, to limit the situations under which you would go along this transition. So, in this case, we'll have a guard that the sex needs to be female, so we'll have sex equals 1. Now you'll notice they put 2 equal signs here. I'm checking the equality of sex in 1. Why do I do that? Can anyone say? How if I said sex equals 1? What would that do? Okay, in this case, it would actually give an error. It's true. It would say that specifically, I can't assign. This needs to be what's called a Boolean, and I can't assign it and get back a Boolean. So in this case, it would catch it. In general, there's many cases where it won't catch it. It would have assigned to sex is what it would have meant. It would have taken the value 1 and changed the person's sex to be 1. Okay? We want doubles equals, which means, okay, we're checking if it is 1. And if so, then we're in good, in that case, we're a female, in which case we can go and become pregnant. So, ladies and gentlemen, I'd like you to try running this model now, and if we need to, what else do we need to do? We need to define sex. Where do we do that? How do we determine the sex of the population? TAs? Who needs TA? So what did I do here? I put for conception, I put sex equals 1 in the guard, meaning only fire this transition under the conditions this is a female. It's the only case. Okay, so how would I define the sex of the population, though? The sex balance of the population. Okay, main, and where in main? Population. Go to population, and you'll notice there's a formula for sex here. By the way, one reason I made an int is because if it were a Boolean, make it is male, all it has is a checkbox here, so you can't specify a direct formula for it, which is unfortunate. AnyLogic, the next version of AnyLogic is fixing that, which is good. So if I want to draw sex from a distribution, I want to draw it, say, from a Bernoulli distribution, or suppose I just want to say with uniform probability 0 and 1. How do I do that? Anyone remember? Uniform underbar discrete, and then the minimum and maximum 0, 1. So it's either 0 or 1 with equal likelihood. Remember this? So for each successive person in the population, we'll run this little formula. It'll flip this coin, and with 50% probability they're male, 50% probability they're female. Does that make sense? Yeah.
What would happen if I would specify that in the parameter and the person?
Okay, so default value.
Yeah.
So the default value gives an expression that will be used. It's very important to realize default value is not initial value. Default value gives an expression which, if you don't specify, say in the enclosing population what to use, that expression will be used. Okay, so if you had done this there and not filled anything else in here, it would work the same. However, the default value can be overridden in the sense that I could specify a formula here, and that will be used instead. So default value provides a convenient way of sort of just giving a formula that's the default formula to be used if no one else specifies an overriding formula in a given population. Does that make sense? Okay. But it's very important to realize it's not the initial value. It's a default expression, and it's good. It's good to be able to provide that if you know what it is. And in this case, it would be perhaps the default. Okay. So ladies and gentlemen, we should be able to run this model. So if we run this, we can go look, we could try to find, okay, now, okay, now that's It's quite interesting. Okay, so here's someone who's pregnant, and indeed it's a woman, sex 1, non-pregnant, sex 1. So we could go through and kind of browse like that. That would be fine. How if we wanted to make it visible whether they're pregnant or not, and their sex or not? Well, we could do that to dynamic properties. We saw that yesterday. So if you wanted to check it that way, you folks know how to do that now. Let's have them, though, remember their mother. How if we wanted each person to remember who their mother was? How do we do that? Each person knows their mother. Who needs TA help here? Okay. If we wanted a given person to be able to know who their mother is, that's an attribute of that person. How do we do that? Anyone? Sorry? We could store their name, but we could do something more powerful than that. So we could store a reference to the mother. The question is, how would we store that? We want to let them store that information. We want to make that an attribute of the person. We made sex an attribute of the person because we made it a what? What is sex? It's a, could we make mother a parameter? Is mother, oh, I forgot to show one thing. This will bring home this point. Folks, let's go, now that we added sex as part of a person's characteristics, what's the sex of the baby? Okay, folks, let's go look at delivery. And we could see, now we do add person. You'll notice now we can actually, oh gosh, look at that. It says double. That must mean in sex in my model. Oh, well, that. Oh man. Okay. This is a most peculiar thing. I don't know why it's requiring a double. This should be an integer, but that is interesting. Okay, so here we actually can specify what's the sex of the baby, and in general, we'll want to draw it also from a uniform distribution between 0 and 1, and that allows us to specify the baby's sex. Right? So this is at time of delivery, we're adding to the population a baby of this sex, and to determine the sex, we're drawing it between 0 and 1. Okay, it's a good question. So when you have successive parameters in place, they should have names and how it's described under add population. So normally it will say, for example, view of sex, and then you had initial age, and then you had ethnicity. When you look at the documentation for add population by autocomplete, it should give each of them in turn.
Okay, so you just put a comma between them?
Yeah, exactly. Exactly.
Is there any way that we can specify a parameter in that, just
To make it clear.
to make it clear?
Unfortunately, Java no. In many languages, yes, but in Java, no. Okay.
Well, you could use like person A equals add population and then start specifying its parameters.
Yes, it would, when the person gets created, it might undergo some basic setup that really needs to know the parameters or what have you. So,
So if you look at the order of your parameters
yeah.
on
Yep.
the name, is that the right order?
So if you were to look at the order of the parameters over here, this would be the correct order. That should be the order. It's actually the order they're added, I believe, based on my past experience with it. But it should also specify. We'll see it in just a minute, I think. Okay. So folks, here we added the sex of the baby as when we create it in the population, we added it sex. The sex of the baby to be created. Let's suppose now we wanted a mother to be able, we want each person to be able to keep track of their mother. What could we use to keep track of that information? So each person has a mother associated with them. Okay, we could do it through their network, and here the network is dependent on who's close by them, and so we could have mothers be located close by their children. In fact, one of the models I provide to you, I do exactly that. The ABM model referred to that. I have that process. But here, suppose we just want a reference to your mother. How could I do that? With each person here is a sex, each person will keep track of their mother. What could I make that reference to mother? I could make it a parameter, okay? So let's add a parameter into person that's mother, okay? Now, what sort of thing is this parameter? In other words, is this a Boolean? Is this a double? Is this a string? Is it a date? Is it a color, or is it other? Okay, so it's other and person. It's a reference to a person. Okay? Okay, now, so we have mother here, and its type is other. It's a reference to a person, okay? So riddle me this, folks. At time of delivery, I now need to specify, oh, okay, look at that, Scott.
Sorry?
This is disturbing to me.
That's very interesting.
Indeed. Yeah. So folks, if I wanted to add a reference to my mother at the time the baby is born, and want to add a reference to mother, what would I put? Who is its mother going to be here? Okay, this is at the completion of a pregnancy. Going back to a non-pregnancy state, I'm adding the baby to the population. I'm specifying its sex. It's just a flip of a coin. What's its mother going to be? Who is its mother? The baby that's being born through this delivery, who is its mother? It's this. That's right. That's right. It's not very flattering, perhaps, but it's this. It's the current agent, right? And Scott compiles just fine. It's the documentation. It's the autocomplete. Okay, so folks, you'll notice here that that it looks like it doesn't properly name the last parameter, but Carmel, you can see that it names correctly the first parameter as sex. It looks like it's just the autocomplete documentation isn't naming properly and isn't giving the proper sort of type for the second one, but it's sex and then mother. So here we're specifying the mother. This is the mother. Mother is this. It's the woman who's giving birth. That's the mother of the baby that's being produced through that birth. Does that make sense? People?
It makes sense.
Okay. So if I'm this woman and I deliver, there's a baby that's produced that's added to the population. The baby's sex is this, and the baby's mother, the other parameter for that baby, is myself. Right? Okay.
Specifying that mother as person, it just has its own ID.
So I'm giving it, so this mother parameter is a reference to a person, so I have to give it a reference to a person. In this case, I give it a reference to myself as the mother. So
Okay, so it's going back because that's the second one.
that's the second one.
So it knows it's the mother.
Yes. So the first one is sex.
The second one is mother.
Right. And so the autocomplete, is that automatically, is it supposed to fill in
Yeah.
those parameters?
It's supposed to fill in all the names and so on to the parameter, but in this case, it's, I think maybe there's some issue with it where it's not giving the correct name for the second one, it's not giving the correct type for the second one, but it knows the information properly. And in fact, can I show you something for this add population? If I were to go look at that, the code for that, this is a case where we might look at code. So if we right-click on, so if I wanted to look at Java code here to see if it's correct, we could right-click on main and say open the Java editor. You never modified this, but sometimes you may want to look at it. Let's look for add population. I'm going to search in here. Okay, there's a use of it. Okay, let's go. This is another use of it. Here it is. There it is, Carmel. This is the actual code. Sex, mother, person, mother. So it's actually got them right in the right order. It's just the autocomplete, it isn't giving the right information. So
You can try to person mother.
So you first have to give, when you add population, you first have to give sex, and then you have to give the mother. And then,
Put those parameters in, if you add the mother first, then the sex would be mother.
and then we mother and sex. That's right. So, anyway, this is a case where looking at what's here, searching it, is kind of useful just to double check as a sanity check. But the main point I want to make, do people understand what's going on here? We have the baby. And so every person's population has two characteristics, sex and mother. Sex is an int 0 or 1. Mother is a reference to a person. That's what information is stored here. It's a reference to a person in the population. So when I create a baby to add it to the population, I'm creating a new person, its sex I determine through a coin flip. And its mother is just the mother who's giving birth to it. Does that make sense?
Knowing how big the real thing is that
Yeah, okay. Fair enough. That's true. And it's an interesting commentary on this sort of modeling that you need to make it this explicit, whereas in fact it's more contextual, right? The mother doesn't need to put a tag on the baby that says, you know, this is mine, or give it a cord to go hold it or something like that. Okay. The other thing, though, the uncomfortable fact that does remain is, ladies and gentlemen, if we go to main, we have an initial population that's created. What are we going to say is the mother for that population? Who's their mother of the initial population? They don't have one. And ladies and gentlemen, if you have a reference, in Java you can have a reference that's not a reference to any particular object. It's a reference to no object. It's a reference that we know is to nothing. It's not a reference to any one thing, and we can test, okay, is this a reference to anything? Yes or no? Is it a reference to a specific object, or is it a reference to nothing? And what do we call that in Java? If we have a reference to nothing, it's called gosh. Oh. We could be. That's a clever name, but for whatever reason, it historically has been given another name, which is perhaps less clear. RTN would probably be just as clear. What is this thing called? It's called null. It's called null. So we say that for the people in the population who start initially, it's called null. But it's just as arbitrary as it could be RTN. It's just that isn't how the Java language designers care to name it. But for historical reasons, it's called null. N-U-L-L. Okay, ladies and gentlemen.
Okay, quick question.
Yes.
So back to the other one, if you were on the transition
Yeah.
and you were writing in sex mother, but you didn't want to specify mother, right? No?
Yes.
And vice versa, you write null for sex and then.
No, null is only something for references, because if, so a null means that this is a reference to no object, so it can only be used for a reference, and sex is an integer, and so it's not a reference, and so you can't say null for that. But if you have to specify, for example, the baby's city, and you have cities in your population as ages, and you didn't have any specific city, you want to say this baby belongs to no city, then you could say null for city, something like that. Yeah. It's not, in other words, it's not like, the word null doesn't make it specific to like it's a null person, it could be a null city, and in context it's gonna know, it can be any of those, but here it's a null person. Okay. So now we have babies, and we have each baby knows their mother, and let's go run this model, and let's speed it up so that we see. Well, I should have looked at it up front, shouldn't I? Okay, so let's run this model up front, and let's pause this model. We can pause it through this button here, and let's drill down, and we could see these people have a mother thing, but it's null. There's no information on it. Okay. What's that? Yeah. Now if we run it forward quite far in time, okay. Now let's stop, and now let's go down, and let's go see who has their mother specified. Okay, there's one that has their mother specified. Oh, their mother actually has died. Okay. Okay. So. Okay, this is interesting. I would have expected that that by now you'd have most. I'm going to run this forward over time. Okay, it's running. I'm going to pause it here in a few minutes. Okay, just running it. Okay, and now I'm going to drill down to see the population. Yeah, these look actually like they're specified. It's just it's not giving the it's not giving me an easy way to say which particular person is its mother. Sorry? Change the what color? Oh, change it to be. I mean, if they have a mother. Sure. Okay, sure. That's a good idea. How would I make it for a person if I wanted to make them have a different color? So if they have a mother, then they're green. Otherwise, they're red. Okay. Okay. Okay, good. So for the fill color for the oval, if mother equals null, doubles equals null, then do green, otherwise do red. Oh, sorry, do red, otherwise do green. Okay. Okay, so folks, Raheem had suggested if you click on the oval and you go down to dynamic properties for fill color, you could have a test under fill by the color of that oval. If the mother is known, then we'll make it green, otherwise we'll make it red. Yes? Yep. So you'd need to compute one final color for that person for their fill color, and yes, you could consider all those things. But principally, you could have the brightness of the color depend on their age and the sort of the level of red depend on their income, and the level of green depend on their sex or what have you. But you could also specify the line color around them and how that color differs, and so distinguish the two different sort of parts of their color. So here we have agents whose color is okay. So yeah, this gives a better understanding of what's going on with all these agents whose mother is null, and then we, you know why? Of course. No, folks, how do we have in this population, how do we have people added to the population now? What's adding to the population? I forgot entirely. There's mortality, removing people, but then how are people being added to the population? Immigration as well as babies. And for the immigration, they don't have a mother. Right? Recorded.
We're asking for health.
A health break.
Yeah.
Okay, we're going to have a health break now. And we're going to, we'll have a health break, and then we'll reform and continue on a different topic.
Dr. Osgood,
Yes.
That we suggest doing.
Yeah.
One, every child should be in a network with its mother.
Mm-hmm.
That would be a really interesting thing to
Okay,
do.
I already have a model which does that,
Cool.
but sure, let's do that. I like that idea a lot.
And then there's also the question of the mother should be keeping track of the children.
Sure, yeah, and this other model has both of those things,
Okay.
but we can do them here. Sure, that sounds great.
I'm just saying that might be.
Yeah, I like that idea. Yeah, we'll do that.
What is the difference when you have
Mm. Mm.
negative numbers for no? When you try to check the index of the mother.
Yeah. Oh, the negative number?
Yeah.
So that's an indication that you have a reference to a mother, but the mother is no longer part of the population.
I'm feeling that you don't have a mother.
And so if it's null, there's no mother at all, but you could have a reference to a mother who's died,
And that's
has now died, and so she's no longer a member of the population, and so you'll get a sort of indication that she has an index of -1 in the population, because she's no longer in the population, but she's still,
so it knows.
you still have a reference to
It
her.
knows that it was there.
Yeah, that's right. Yeah. Yes. Yeah.
The schedule says
Yeah.
lunch is at noon,
Yeah.
but we went on last time at 1. I think, I was sort of under the impression that it was 1 o'clock. She told them 1 o'clock.
Back to the club?
Yeah. this
Oh, no,
was-
no, we should tell them it's the earlier time, because Gregor's planning on the earlier time. I don't think it's noon, I think it's 12:15 or something, but 12, oh, it is 12 o'clock, yeah,
Yeah, it's
yeah,
12.
it's 12, okay.
Okay, so we're doing 12.
We are doing 12.
So then, I'll just, good, thank you.
Yeah, sure. Hi.
So at one point, at any point, will we add generations?
Um,
Like have mom, grandma, and baby?
Yeah, we can,
Or is that, we should wait on that?
that's a good question. So right now, you could have that in the model, so in other words, there could be, mums and or grandma, mom, and baby, because you'd have baby having a mother who's also in the population. She has a mother who's also in the population.
Yeah.
So yeah, we could have that. That's an
Is
interesting.
that difficult?
No,
'Cause,
it's
you know,
actually
you'd like
already
to model
supported by this.
Multiple,
Yeah,
health effects
sure.
across. Okay.
Multiple generations,
Yeah.
absolutely. So okay, I'll see what we could do in
Okay,
concrete
or we can
terms
wait later.
to add that in, so we could see it. Okay.
Thank you.
Okay, thank you. Yes,
Logistic question.
sure.
Do you think that I should participate, or is because I know most of the stuff, I mean, kind of unfair?
Oh, I see. No, I think it's good, actually, sure, if you'd like to, absolutely.
No, I mean, it's more up to you than to me.
Yeah, yeah.
Because if I'm gonna be answering most of the questions, make no sense in a way. Or maybe I don't, but you know,
Right.
It's
Um,
whatever.
so, it's a good question.
Instead, I'm asking questions sometimes because well, if I don't know something, I ask.
So what you could do is, you could ask more advanced things sometimes, or you could volunteer, some idea. That's also good. But yeah, I mean, if I'm asking a question and it's obvious to you, but it's not obvious to others, probably it's not that great to sort of to ask immediately, or to say immediately,
Yeah.
because it doesn't give them a
The
chance
chance, right?
to engage with the question. So I appreciate you asking, but
No, anyway, I think I continue more or less the way, just asking some questions here and there.
sure, that's good. That's good. Yeah.
Fair.
Okay. Thanks very much.
The Russians love it. I don't understand it. I'm just like, I never use it. Well, it might be, but it's like, as you said, it's very compact. I think it runs a lot faster than anything else would, or anything else solution. I was reading. It's very cost effective, but I never use it. That's because as you said, you can't read it. They're like, what does this say?
What you really want to do is design everything so it's readable first, and then if you find out like, well, this is 3 times as slow as I want, then you go and find out this is my slowest, and then you start changing it.
Okay.
That's
This is logical. No. It's a lot of logic. For example, you have like the first model we looked at, the 22,000 agents, and you have the something spread. And when we increase the duration of the illness, it slowed down. Why? Yeah. Well, actually the entire model slows down. But it does for why? Somewhat, you're close. The reason is because you have more agents that are infected, and the infected agents send messages. And even though those messages are doing nothing, agents are still receiving them. Because I'm sending a message to someone who cannot be infected to say infect you. So one way to do this is to actually like check to see, like, for example, if you have no infected, no neighbors that can be infected, you can, yeah, and if there's nobody if there's nobody you can infect, don't send the message. Also, like for example, almost all SEER models have both a contact rate and infection probability, right? Well, technically speaking, you actually send contact rate messages for infection out per time unit, and each of them has an infection probability chance of actually working, right? And so instead of modeling all these messages, let's say this is like 0.1, and this is 5. If I could model it as saying, you know, send out 5 messages a day, and then the transition that fires is when you receive the message with a guard action of 0.1 at a time. Probably 0.1 it will fire. Okay, but that will send 5 times, or that will send 10 times as many messages out. Whereas if I just multiply these two together and get a composite of 0.5, I'll send on an average 0.5 messages out, but they will always infect someone. This is a way of speeding your model up because you're sending an order of magnitude less messages out. But this is actually somewhat, depending on how accurate your model is, it may not make a difference. But if it's really important and idiosyncratic, you might have an issue doing this. Okay, but that's just one example of how do you speed your models up.
Wow.
Reducing the number of messages sent in agent base is very important.
Very good.
This is one of the things I have to answer a lot is, they ask how scalable is AnyLogic. As far as I know, it is probably the most scalable database software out there. So that's good.
Yeah, we're going to be starting again here soon.
But,
As well. Very good. I appreciate that.
that's good. We normally sell to either departments or researchers. So the departmental license, what you're using right now, is like $300 for the entire department. And as you see, it covers all the K-12 students, all the labs. Research, this is going to be for people who do like lots of big grant work and or external research in the university. That is like $3,600 per month. Educational, and we sometimes do offer a single educational license. We don't really offer it because we're going to do it.
Okay, we're starting again here.
Okay, so we're gonna, responsive to sort of some requests we got, we're gonna do a little bit more refinement right now here. So while you folks were gone, there was one thing that was puzzling me, and I checked it out and realized what was going on. So right now, when we run this model, we were seeing we're having an immigration of 1 person per day, and if we run it, what we'll find is that most individuals within this population are in a state, they're red, where they don't know their mother. We had modified it so that they would appear red if they don't know their mother, green if they do, and you can see they don't have a record of who their mother is. I turned off immigration here just to see the effects of that by setting it to be a rate of 0, and tried running the model again here, and you'll notice that the population very quickly is eliminated without that. I was wondering what was going on. And one thing I realized is that, and this is a good lesson for future models, mortality rate is set at 0.01. Okay, what does that mean? The average time, the average life is 100 days. 100 days is quite a bit lower than the gestation period. So there's very few babies being born because most mothers are well, yeah, they're not making it through their pregnancy. So we're having very few births there from there. It's a good lesson in being very careful about units within your model. If we were dealing with years as the time unit, we would perhaps have 1% be a generous mortality rate. But here, if you click on the model type, we're dealing with days. So if we wanted to convert that from years to day, have the mortality rate be expressed instead in days, we would need to divide it by 365. And now we would have it expressed on a per day basis, this hazard. So mortality rate was way too high. And what that was leading us to was incomplete pregnancies, cases of maternal mortality during pregnancy, and therefore many fewer babies being born. So that was one issue. The other issue is because we've now subdivided the population so only females can give birth, the fertility rate should really be twice the mortality rate to stay in balance, because it's fertility, it's female specific. There need to be babies, enough babies produced by every woman to sort of cancel out the mortality occurring for both parents. So the mother needs to have a fertility rate of twice the mortality rate. So those are the two things that I changed here. And if we run that now with this new situation, now we see a situation where people are more in balance, but we don't see a network. Why don't we see this network in place? Do you remember where we formed that network before? It was for immigration that we knitted people together. Now we have these babies being born, and if we go look at that within the person, we have this baby being born, delivery occurring. That baby is added to the population, but they have no connections being added. Now, we could add connections in to the nearby people, but suppose we wanted to add the baby into the mom's social network. How do we do that? Suppose we wanted this baby to be added to the mother's social network. Sorry? Okay, so this baby has been added. Do you remember how we can add, I mentioned it earlier, how we can add connections between two individuals? Well, for the mother, we could say this dot connect to another agent. But what agent am I going to say to connect to? Who am I going to connect the mother to? Connect to the baby. So I've just added this baby to the population here. It turns out this add population, it both adds it to the population and it returns a person, the new person. So I have to remember who this baby is, and then I can connect the mother and baby. So how could I remember in Java what the result of this was, so I could then add it to the mother's social network? Can anyone tell me? Well, I can introduce what's called a Java variable, and this will be a person variable called baby. Okay, so I'm going to add it. I'm going to just it's a name for a reference. Baby is going to be some reference, and it's a person, and so I have to say person here, and I can assign it to be the result of this add population. Okay, and that will give me that will add the baby to the population, but it also gives me back a reference to the baby. And then if I have that reference to the baby, how can I add the baby into the mother's social network and vice versa? What would I have to type? Sorry? Okay, I'm actually going to add it directly. This dot connects to, who is this here? It's the mother, and I can say connect to baby. Now the baby and the mother are going to be connected in a social network. They're not necessarily going to be located close by each other. If you want to see that, go check out my agent-based model with birth-death, where they're located close to each other. But I could connect the mother to the baby. So what am I doing here? At this time of birth, I'm adding the baby to the population with myself as the mother and picking the baby, myself as the mother, picking the baby's sex randomly. That gives me a reference to the baby, and then I'm adding the baby into the mother's social network. That's a good question. I could do that, but doing that would require a little bit of, well, I mean, it could be done. It would require a little bit of mechanism that I don't want to get distracted by right now. Okay, so, but I could add them in. It'll be much easier to do. That will be a piece of cake in the new version of AnyLogic. You could have a distinct color for that type of connection, because it'd be a mother connection, for example. Okay, connection with parents. Okay. Oh, okay. So it's exhibiting problems. Okay, so it refused to connect. So what just happened there? Let's go see that. I tried to run it, and it gives me this thing in the problems window, and it behooves me to read these things very closely. It says method connected to. I must have mistyped it. I meant to say connect to, not connected to. Connect to. And how would I know that? Well, if I do, I could start typing connect to. Okay, so here I'm connecting to the baby. Okay, so I'm the mother. I'm connecting to the baby, and now I should be able to run this simulation. Who needs a TA here? TA? Who needs TA? Okay, so now we have these individuals, and now we have individuals being connected longer distance. What does one of these long distance connections mean? Those are the connections to the mother. If we go down and look at the individuals here in the model, we could sort of go through these. Sorry? So here, for example, is a connection between a mother, between a particular individual and they have three connections here. One is to their mother, two are to children, and their mother is person number 7 in the population, and they're person number 20. Okay. So here we've just added in connection between a baby and its mother. Okay, which is a persistent connection. I'd like to further do a little exercise here where the mother keeps track of her children, so that we'll have for each person a record of who their children are. So, and then we'll come back and explain some pieces of this. So, okay, who needs TA help? TA? TA help is needed over here. What's that? Yes, yes.
So, like, I have in a variable that is the number of
Number of,
people that have died,
yes.
and even with the rate of also being lower than the market, including the rate,
Yeah.
they still a very high rate of
It's quite high mortality rate right now. Yeah, it's true. It's so you changed the mortality to be 0.01 divided by 365. Is that right? So I think each person should live on average about 100 years right now, if I'm not mistaken, because they will be dying at the mortality rate. So we'd have to look why that is if you're experiencing a very high mortality. But you're right, there is some mortality going on. There's no question. But what's the time scale in which you're seeing it? Like here we're out to time 239,000 days here, which is like 100 years. So that's many, yes. Sorry? Okay, did you turn off immigration? Is immigration off?
Yeah, so I had the same thing, and then turn off immigration, it just gets.
Yeah.
Immigration makes the population more substantial.
Yes, indeed. Okay, so who needs TA help here? Where did the TAs go? Yeah, the outside TAs. So where's Winchell and Juanita? Oh, okay. Where's Winchell? Okay. Yeah. Who else needs help? Okay. So did that fix that problem? Okay. Okay, sure. So folks, I want to do one final thing before we wrap up this example, and that is let's have first of all, we're going to look at what's going on when we run it. So when we run this, we run the population forward here, and what we'll see is increasingly it's individuals paired with their mothers. You'll notice the time is going very, very quickly. So this is day 276,000 or so, which is, 3/4 of a century, something like that. Well, not quite 3/4, but much of the way through a century. If you scroll down, if you go down to the level of individuals here, you'll find that individuals are connected sometimes with mothers who are no longer, quite frequently with mothers who are no longer part of the population. For example, this indication here is this person's mother was in the population, but now she's removed from the population, presumably because she's passed away by that point. Here's a person whose mother is still in the population. This is someone whose mother, this is person number 17 in the population, whose mother is person 11 in the population, okay? So person 11 in the population back here is the mother of person 17 who is in the population, okay? This is person 17 whose mother is number 11, and that must, and they're associated with a link to their mother. Okay, I'd like to now have each person within this population keep track of their children to whom they've given birth. So each woman could keep track of the children to whom they've given birth. How would I do that? If I wanted each person to keep track of their children, what would I need to add in? Okay, we'd have a children. It turns out that generally when a person is created, we don't know who their children will be, so it will be something we'll have to build up over time. In Java, and AnyLogic, and by extension, Java has this thing called a collection. And we can drag it from the palette, from the general tab of the palette, and we could call this child's collection, okay? So drag it from the palette up here, a collection. And this will be keeping track of children, okay? So drag it from the collection here, it would be child collection. And you notice it says some information about the collection class. For the elements class, what is this going to contain? If we want each woman to keep track of her children, what would those children be? If we want them to be in this collection, what are we going to be storing? We're going to be storing references to what? Yeah, to person. So these are going to be, the elements are going to be person, okay? In other words, we're going to be storing for each woman references to each successive child. Okay? So that's step one. Step two is, suppose we now want to, so now we have to figure out where to put the information in here. Where are we going to have the woman add her child to this collection? So we have this collection. Where will a woman add a child to this collection? At what point will there be a new child? Delivery. Okay, so at the point of delivery, just after they connected the baby, what are we going to do? We're going to, at that point, do what? Can anyone tell me? Add the baby to the collection. So how are we going to request that? We have to ask the collection, add the baby, right? This dot child collection dot add, and we have to give it a child to add. What are we going to add in? Baby. Okay? So I'm gonna make this a big window so you can see it more easily. This is what I have here. So this was there before. This was there before, but now we have this dot child collection dot add a baby. That's going to add this baby in to our child collection. Okay? So folks, we have this collection object. It contains references to person, namely references to each child, and we'll add those children into it over time. Okay? Okay. 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 Good. Okay, should we run this? Who needs help here? So we've just added this child collection, and then at point of delivery, we just add the baby, the new baby, to that child collection. Let's run this. So now we're going to be able to have a reference to mother and a reference to children. Let's run this thing forward some. And, excuse me. I'm not sure what's going on here. Let me try that again. Oh, okay, sorry, I ran the wrong. Oh gosh, I ran the wrong model? No, okay. Where am I? Okay, there we are. Fine, I ran the wrong model, sorry. Okay, so now we're gonna run this, and I'm gonna run it there, and we're gonna go down to this population, and let's go through each population member. We're trying to find one here. Okay, here's a woman. She has 13 children. Some of them have died already, and some are still living. Some are still living. So, for example, this one here. So here we have a woman with quite a few children. Many people have yet to have children. Why is it that so many people have no children listed? What's that? They're males. That's right. So they have no children being recorded. but a number of other people do have children. So, for example, this woman has these 5 children being recorded: number 27, number 75, and number 85. And so we could go into the population and look at this. And for example, okay, so that was the case of a grandmother, and then that grandmother had this woman as a child, and she has herself 2 living children, number 68 and number 84 here, okay? So they have 68 and 84, and so we have some grandmothers in the population, we have some mothers, and we have some others who are younger children. Okay.
So that's good.
Okay, so now we have a way that each person remembers their mother and also remembers their children, and we can actually look intergenerationally at what's going on, because we can follow the children and the children's children and the children's children's children, etc., all within the context of this model. Some of those individuals will be dead, will no longer be living, but some will be. So the ones who are no longer living, when we see them referred to, will be referred to as root.population -1. That means they were in part of the population, but they're no longer part of it. They're now gone for the population. But others will be, like, here's a woman who has children, each of which who have now passed away. Other individuals will have kids or mothers who are still alive. For example, this woman has 2 children who are still alive and 4 children who have passed away. She has a mother who has passed away. So, yes, Carmel.
So, is there a way that when they die, it seems like they just kind of fall off and they are suddenly assigned to the idea again?
Right.
Is there any way that you could retain the identifier for all of those children?
Okay, so this is a great question.
Oh,
So these people who are given -1, okay, this is going to take a little bit of subtlety to explain. These people are no longer part of the population because they're dead, but they're still in the model as people. So all their information is still here. It's just that when AnyLogic's way of kind of denoting them is it gives them a name based on their location in the population. Because they died from the population and disappeared, they're no longer in that population, so it gives them this. But all their information, any history information, the information about their children and their children's children, is actually still present. Okay, so great question. So I am going to, I like your question. I'm trying to take the most artful way to demonstrate this. Okay, so how do we give each person in the population a unique ID that transcends whether or not they're in part of the population or whether or not they're dead? It would be a unique ID that persists for that person and can be used to identify and list information even about people who are now passed away out of the population. Would that be of interest? Good. So, we will do that. I'm hoping that by doing this is going to require a little bit of stretching. I'm hoping that by doing this, I'll give you a pattern that you can reuse many times. Okay? This is going to be something which I've only had to do once before, but once done, you could just reuse it very easily. Okay, so folks, we're going to give everyone a unique ID. We could give them a unique name if we wanted to, but names are kind of hard to generate to be nice. So I'm gonna give them an ID. It's gonna count up from 0, 0, 1, 2, 3. And regardless of whether they're still in the population, in other words, regardless if they're still alive, they'll still retain this ID and we can still find out. We can have information on them if we want, okay?
Okay. Okay, so what I'm going to do is this, double click on person. I'd like to drag in a variable, and it's going to be called, let's call it person ID, okay? And this is going to be an integer value.
Okay. That's going to be their unique ID.
We're going to drag in another variable called next ID. Okay? And that also, oh, I'm sorry, both of those should be ints. Yeah, they'll both be ints. So next ID and person ID will be ints, okay? But next ID, we're going to do something a little bit different. And I'm going to ask for your apologies. I'm going to ask apologies to you for doing this. But I'm going to teach you something that's a little bit different. See, it says static. I'm going to select static here. Select static. And what that means is this is going to be a value that's associated. So this is a terrible conflict of names between dynamic modeling and Java. Static in a Java context means that this is a quantity, there's only one of them for the entire class. No matter how many people there are, there's only one of them, okay? This is going to be a next ID. There's going to be a unique next ID to dole out for the entire class. And with each successive person that's added, that's going to be incremented, okay? So there's going to be, it's going to be a static value. In other words, a static variable. There's only going to be one of them for the entire person class. By contrast, each person is going to have a person ID, okay? Okay. Now, the initial value for person ID is going to be given by next ID, but we are going to increment next ID at the same time. In other words, we're going to increase the value of this sort of next ID to be given out. So each person is going to have an ID whose value is going to be taken. In fact, it's going to say constant after that. The value is going to be taken from this next ID for the whole person, the whole person class. Okay, so that's the mechanism there that I've done. This assigns each person an ID. Okay, it's a bit ugly, but this works. So first of all, let's run the model. Let's go check if people have unique IDs. Okay, so with this in place, we're going to run the model, and let's run it forward. Okay, there we go. And now let's drill down. So this is person ID number 60 within the population. This would be person 125, 230, etc. And you'll notice it's still saying mother is, because this is just sort of AnyLogic's way of saying that. What I'd like to do, Carmel, is I'd like to provide an easy way for you to find out what's the ID of your mother, okay? This person ID of your mother. I am going to set it so that when we click on a person, it prints out the person ID of their mother, okay? When we click on their oval. How would I do that, folks? So if we want it so when we click on someone's oval, it prints out the person ID of their mother. How would I do that? Okay, so we have to click on this oval. We have to open up person, first of all. Click on the oval, right? And then I need to, in the dynamic properties here, I need to go down to on click, and what should I type? If I wanted to print out the ID of their mother to the command line, to the console, well, I can type trace ln, and I could say my mother's person ID is, and then we, after ending that quote, we do plus, and I could say mother dot person ID, okay? That's what we do. Sorry, not method, mother, thank you. Okay, let me make that clear by this is what I had there. So where did I put that? I went to oval, I went to dynamic properties, I went to the on-click handler. What does it mean to put something in the on-click handler? What does it mean that this is in the on-click handler? That means that what? This will be fired when someone clicks on that oval. This action will be undertaken. Trace ln means print it out to the console, and it's going to print out this statement, my mother's personal ID is, and then it's going to print out her ID, okay? So here we go. I'm going to run this model now, okay? And I'm going to run this forward in time, so pretty much anyone has a mother here, okay? And then I want to go click here, and you could see it says my mother's person ID is 487. My mother's person ID is 371 or 332. The mother's still around. The mother is still around. And my mother's person ID is 471. All the information about the mother is still around. We could have printed out how many children the mother had. So how many children the mother had? We could have printed out the mother's age when she died, or the year she was born. Any number of different properties about the mother. Person ID is just one of them. So all that information is still around. We could even here, Carmel, along the lines of what you're saying, if we wanted to, we could have a complete list of people who have ever been born. Regardless of whether they're still alive or not, we could store that in main for easy reference by their ID number. Sort of one after the other, so we could go there and sort of look at information on them. So all that information is in fact present, even though the person is gone from the population. Does that help an appreciation for that? Yeah, okay. So any other question on that? Before I'm gonna move on from this topic. Maybe because some of them don't have a mother? Or, okay, that's, sure. The piece of code is here. Now, what I want to emphasize here is, I don't know how much, I don't think Carmel's particularly interested in just knowing the ID of the mother, although that's one useful thing, but the point is, we could print out any information here about the mother. We could, in fact, sort of related to what Jennifer was asking about, we could have a complete intergenerational history now. We could say, my mother's ID is this, her mother's ID was this, her mother's age of death was such and such, so we could give all sorts of information here, because all that information is still around. We still have references, and the big lesson here, folks, is that just because someone's gone from the population doesn't mean their information is truly gone.
as long as there's references to that person, to your mother or whatever, that information is kept around. It's kept around, so you could write it to a database, write it to an Excel file, whatever. This complete intergenerational history. That's still accessible in the model if you keep track of your parents, etc. So here we have intergenerational components. Maybe, folks here, maybe I'll just do this one step better. How if we wanted, when we click on that person's icon, instead of just reporting their mother's person ID, suppose we wanted to report how many children the mother had total, so far. How would I do that? What code would I write to ask how many children my mother had? If I wanted to modify that to ask how many children did my mother have, what was her parity? Okay, good. So on click, I could say my mother's parity, in other words, her number of children that she's had, is mother dot what? What information associated with the mother would allow us to determine the number of kids she has? The child collection dot size. I could ask for the size of the child collection. That's going to be the number of kids she had. If the child collection has 0 in it, well, it's not going to be 0 because I'm the child. If it has one child in it, this is going to be 1. If I'm the only child, it's going to be 1. If there's another child too, if she had 2 children, the mother's parity would be listed as 2. I'm going to put this up on the thing here. This is what I just put. Asking for my mother, I want to know for her child collection, what's its size. Now, ladies and gentlemen, I'm teaching you bad software engineering. This is, I would, okay, TA, what would be much more preferable is to say, have at this point something that calls to the mother and says, report your biography. And then she would say, my ID is such, my person ID is such, my child collection is, I've had these many children. This is not good practice from a software engineering perspective. Okay, so let's run this. And now when I go click on one of these, boom. If I click on a given person here, it's to say my mother's person ID is 384 and her parity is 8. Okay? This is reporting the number of children the mother has had to this point. So TA? Okay. This is the code. So TA help? TA help? Okay, so the point here is we can access information about people even they're gone from the population, even if they have died in the model, their information is still around. As long as we have a reference for them, we can still refer to information on them. Okay, TA, maybe, because Alex just came in, so maybe you want to take a look at this part. Okay, yeah, actually, that's a good lesson. Let me tell people that. Okay, folks, I want to show you something. So folks, what if I click on someone who has no mother? Watch this. Suppose at the very start of the model, I were to go click on someone. What's going to happen? Look at that. What does that mean? Folks, this is a valuable thing to understand in life. What does this mean? What it means is I tried to do something with a null reference. What does that mean that it's null? I talked about that earlier. Okay, it's a reference which points to nothing. It's this distinguished reference that points to nothing. And it actually tells me where this is occurring. It's telling me it's on shape click when I'm clicking on something. Okay, that's good. Folks, what would happen if I try doing this with someone who has no mother, where mother is null? It's trying to do this, and it says, I can't do this because there's no mother that exists. I have no reference to a mother. So to make this be able to handle that, we should really put some sort of guard against that. And just for simplicity right now, what I'm going to do is I'm going to put an if statement here. If mother is not equal to null, in other words, if we have a mother that is known, then when we click, we will do this thing. And I'll go put this in that larger window. Okay? There. That's what we should do. Okay? These are curly brackets. If mother is not null, in other words, if I know my mother, if I have a mother that's designated, then do this thing. Okay? Okay, TA help needed? Okay. Okay, so that was a good example of something bad that can happen when you assume that you have a reference and you really don't. Okay? Okay. Think we're okay? Okay. So folks, are there any questions about this before I wrap up that lesson and just finished with some closing remarks about networks, etc.? Yes. Sure. 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 So I could do that right now. Okay. So Dylan, give me just a second here. And there we are. Okay. So Dylan, it should be there now. It's called Minimalist Network with ABM Network ABM model with open population ABM-B 2013. Okay. Yeah. Okay. So I'm going to